Well, I'm happy to see so many people at 12 o'clock when it's usually time for lunch. So, anyway, I'm going to be talking about stuff that's beyond PHP, stuff that's a little bit outside the code, stuff that's connected to all those pretty pictures up there and a few more. Let me start by telling you who I am. My name's Wim Godden. If you want to follow me on Twitter, that's my Twitter handle. I'm from Belgium, from a town not far away from here, about 40 minutes. We have a beautiful abbey and a couple of castles and stuff like that. But I started a company about 15 years ago called Cube Solutions. We're based in Zaventem, very close to Brussels. We do mostly PHP consultancy. But I've been doing stuff with open source since around 1997. And I've worked on tools like OpenX, PHP compatibility, PHP consistent, and Nginx Slick is a project that I'm working on right now. And I've been doing talks like these for the last couple of years. Quickly want to tell you something about the company because I'm going to get back to that. So we do open source stuff, mostly PHP. We do training courses and stuff. We do a lot of stuff that's outside of PHP as well. So we have our own high-speed redundant network with multiple uplinks, where we use a couple of those advanced protocols. And we do a lot of stuff with high scalability. And that causes us to run into certain issues that we'll get to later on. Our customers are mostly IT and telco operators, but we do a lot of stuff that's on public-facing apps, so real websites that are hit quite a lot. Okay, that's enough about me and the company. Let's see who you are. Who here is a developer? Who here is not a PHP developer? Oh, interesting. I like it. Yeah, I mean, we're spreading the word. That's good. Who here uses MySQL? Okay. Who here has ever set up a MySQL master slave? Quite a few people. And I expect more hands to be raised on the next question. Has anyone ever set up a site or an application on a separate web server and a separate database server? Keep your hands up. How many of you know how much traffic runs between the two servers? Not so many anymore. So you can see where I'm going, right? We're going to talk about stuff that's a little different than what you usually see. So the topic here is the stuff we take for granted, or those famous last words, yeah, it should work just fine, also known as, it works fine on my laptop. Now, what works fine today on your laptop might not work that well in production tomorrow, so that's basically what we're going to talk about. I will not be discussing the most common mistakes. I guess we've all made those, we all know them, and we've all learned from them, right? But I want to talk about PHP and how it interacts with the larger PHP ecosystem. But of course, it all starts with our code. Now, what's the thing that PHP interacts with most? Yeah, databases. So let's talk about databases. I'm going to be talking quite a bit about databases, actually, especially in the first part of this talk. I don't want to talk too long about, you should not write queries like these. Can anyone tell me which tool created this query? Drupal, my favorite tool, not. So I can see things here like plus interval 0 seconds. What? Why would you add 0 seconds to something? And there's where clauses here that are duplicates, like the same where clauses 15 times. This is what you get when you allow some kind of tool to just run queries that you don't even know about. You don't actually know what that project is doing to your database. So I don't want to talk too much about it. It's just don't do this, please. Now, indexes are a different matter. Who here uses indexes on their database? Okay. Everybody who's not raising their hand, please have a look at indexes and why they're so useful. Because there were a lot of hands that didn't go up. I just want to illustrate quickly with an example here, why knowing what an index does is important. So if, for example, we have this query here, select ID from stock where status equals to order by quantity. My question is, where do I put an index on the stock table in this case? Status and quantity? So two indexes. Sorry? Depends on the particular query. That's a good one, actually. So in this case, if it's MySQL, I would put an aggregate index on status and quantity, so one index on both fields. Now, what if I do this? Put a greater than sign instead of an equal. Is it still the same? Now, you're all probably thinking, nah, it's not going to be the same, but it might be a trick question here. So, is it still status and quantity? Any ideas? Yeah, go ahead.
It will be the same index because it will just arrange fine the index.
Okay, so the answer actually in this case is yes and no, because it depends. It depends on the type of index that you're using. If you're using a B-tree index, then the answer is yes, it's still the same. If you're using a hash index, then as soon as you hit that greater than sign, it's going to stop using the aggregate index. So in that case, you need a separate index on status and quantity. But then that only works on MySQL 5.6 or higher, because on older versions you couldn't have two separate indexes in one query. So this just illustrates that it's very important to know not just how indexes work, but also how they will work in your specific case on the specific index type that you're using and on the specific MySQL version that you're using, or PostgreSQL or Oracle version that you're using. Now, we know that indexes make databases faster. So some people have this idea, let's just index everything. So there's a table with 10 columns, so they put 10 indexes on them. And then they start creating aggregate indexes across them. Now, this might not be the best idea, because every single time you do an insert, an update, or delete, basically modify your database, you have to update those indexes. So if you have 50 indexes on a table, you're going to have to update all 50 of them. At the same time, every time you do a select query, you're going to actually have to evaluate to see which index would be the best one to use for every select query. If you're doing 10,000 selects a second, you're going to evaluate all those indexes for each and every select. So that's not a very good idea. This is a quote by Bill Carwin, who works for Percona Software, which is a fork of MySQL. And he says, relational schema design is based on data, and index design is based on queries. Basically, that means when you're ready to start designing your app and you're looking at the data that you have, that's when you create your table structure. But at that very moment, the only indexes that you create should be your primary and your foreign key. Don't create any other indexes, because you don't know what you're going to query on yet. Only when you're actually writing your app and writing your queries, that's when you add those indexes. And that way you have just the right amount of indexes on the right fields. So let's imagine you have a database query that takes 15 seconds. How do you detect that it's there? There's a couple of things that you can do. I'm talking mostly about MySQL, but most of these features exist for PostgreSQL and Oracle and Microsoft SQL Server and many others. One of the things you can do is turn on the slow query log. Either enable it in the configuration file, or you enable it by saying set global slow query log equals on. And what this will do is it will write queries that take longer than a certain set amount of time to a log file. You can also define how much time, of course. By default, it's something like 5 seconds, I think, which is way too long, of course. There's also a MySQL specific function that is log queries not using indexes. Now, I don't have to explain what that will do, I guess. It will just log the queries not using indexes. Now, these are, of course, really interesting to look at, because you might want to add an index somewhere for that query. Beware, that function only works if the slow query log is on. That's not very well documented, but if you try to use the second one without using the first one, you're not going to see anything at all. The third thing you can do is you can turn on the general query log. This is going to log every single query running on your system. If you do that on a production machine, don't forget to turn it off, because if you're doing 10,000 queries per second, you're going to have 10,000 lines of items in your log file, and that can actually bring down your entire machine. Now, you might wonder, why would I want to log every single query running on my system? What's the point? It's going to be way too much. Well, actually, there's a nice tool called PT Query Digest. It's part of Percona Toolkit. And if you run it and give it that log file, and it's going to give some very interesting output. And it's going to look a little like this. Now, it might be hard to read at the back, but basically, it's just lines with queries. So it's going to aggregate the results and say, oh, this query is being run 16,000 times, for example. The first one here is being run 16,000 times, and it takes, 1,200 times actually, and it takes 13.6 seconds per query. So that's obviously a query you want to look at. So it will list up all these queries, but this is only the first part of output from PD Query Digest, because underneath that, per query, you get even more stuff, which is completely unreadable at the back, I'm sure. But this will tell you like, oh, this query spent this much time waiting for a lock. I examined that many rows. I retrieved this much data from the database, and so on. So a lot of details that will help you to really debug why this query is so problematic. Now, this is really when you want to get down to the very nitty details of a specific query. But there's actually an easy way in most database systems. Oh. Oh, this is funny. My antivirus just, what the? Yeah, so there's a function called explain in MySQL. Again, exists in other databases in a similar way. And what it will do is it will tell you how MySQL will execute a specific query. So you just say explain, you give it a query, and it will output stuff like this. This is a very simple query. It's just a query on the employees table, and we can already see that there's something not right. The possible keys on that table are null. So basically, there are no indexes there. As a result, we are not using any keys, and we're retrieving 300,000 rows using that query. That's not a good idea. Now, if we have, for example, a join here, we have a join between two tables, but there are possible keys, and we are actually using a primary key, resulting in the retrieval of just one row per table. This is much better. And explain allows you to see all of that. It also has a column called type and a column called extra. Now, if in type you see system, const, or ref, that's all good. If it says all, then it basically means you're retrieving every single row in that table. If you have 50 million rows in there, not so good. The extra info, if it says using index, that's obviously very good. If it says using file sort, unless you have a very small table, it's usually a bad sign. Now, for and for each. I want to talk about that a little bit. What's the problem with for and for each and database queries? Can anyone tell me? Why would you not use database queries and a lot of for each stuff? What could be the problem? Anyone? Have a look at this code. I hope that's readable at the back. Let me maybe make it a little bit bigger. Very quickly. Okay. So we're using some kind of ORM tool here, and we're retrieving customers that are in the state of Minnesota. And we're looping over those, and then we're going to fetch all the contacts that are attached to that customer. And then we're going to do some stuff with the contacts that we retrieved. Now, this works fine if you have 5 customers. If you have 10,000, that could be sort of an issue, because then you're doing one query to retrieve your customers, and then you're doing 10,000 to retrieve all the contacts for each of those customers. You're doing 10,001 queries. Whereas an easy solution would be to just write a join across it. Now you're doing one database query to retrieve exactly the same amount of information. That's going to be a lot faster, of course. The problem is a lot of people are still writing those for and for each loops across database queries, causing massive overload on both your database server as well as a little bit more processing on the PHP side. Usually that happens because, as I explained, it works fine for 5 users, but then your company buys another company and they have 1 million users, and suddenly it runs into serious problems. The other case that I've seen happen is there's an internal application. It's being used by 5 people on a daily basis, but They're just internal users. They're not using it that hardly. And the manager comes along and sees that application and says, our customers could actually make use of that. Let's put it online. Now, instead of 5 users, you have 1,000 users using that app. And then those for and for each loops, of course, cause issues. Now, why did I want to give this talk? Well, basically, this talk is sort of like the stuff that we got from projects. We build stuff for customers, but we sometimes also get like pulled into projects when they call us like, oh, we have an issue, or when we need to do a migration, and then we figure out that there's certain things wrong. So this is sort of like 15 years of how to cause total havoc with 2 lines of code. And I want to illustrate that by talking about 3 customers, 3 customer cases. I'm of course not going to give their names because I'm Belgian and they're Belgian companies. So I'm going to be calling them X, Y, and Z. So let's talk about X. Client X, it was a job site. So you could go to that site and you would type, I'm looking for a PHP job. You type PHP, you click search, and you get 50 jobs. And then you could click on a job and you get details about that job. And basically they were monitoring how many times a certain job was viewed, and they would keep logs for daily hits, weekly hits, monthly hits, and then they would also keep a log of which user saw which job. And they put that in tables, 4 tables, shown today, shown week, shown month, which contained the job ID as a primary key, and the number of times the job was shown. And then they also had a table called shown user, which contained the job ID, the user ID, and when it was shown to that user. And this worked fine. They would just reset the shown today once a day and the shown week once a week, and so on. Works fine, no problem whatsoever. Now, the thing is, originally they were logging when someone actually clicked the job and saw the full description. And then someone in the marketing department decided, we want to change that. As soon as you type PHP and you get 50 jobs, we want all those 50 jobs to be updated. Okay, fine. So the developer, we didn't build the code, but the developer internally decided to make that change. That means if you have 50 jobs to be updated, you're running 50 updates for shown today, 50 for shown week, 50 for shown month, and those 50 inserts for shown user. That's 200 queries for one search. That might not be ideal. And this is the actual code they were using. I'm sorry if it's too small at the back, but basically you can tell already there's a for each here. So this was the original code they had, and then they just put a for each around it. It works, you know. Now the issue is that they were a customer not because we wrote code for them, but because we did a MySQL master-slave setup for them. And we set it up, and it was running quite nicely. We got a peak for something, I don't know what. And then all of a sudden you see that stuff is happening here. But this thing was running, well, up to 1,600 inserts per second, up to 2,600 updates per second. But it was a 16-core CPU machine. So it was handling it perfectly. No problem whatsoever. Until like 2 days in, the client calls us, we got this mail from the monitoring system that you set up. The MySQL slave is now running more than 5 minutes behind the master. What is going on? Now, we set it up. Who do you think they blamed? And we said, yeah, okay, there's a problem, but hang on. What's causing those peaks here? I mean, we didn't change anything to the infrastructure, and everything worked perfectly before. So what is going on? So we said, dear developers, did you change anything? And they said, nah. So what do you do in that case? You know, you're stuck. They didn't change anything, and all of a sudden, the slave is lagging. So the only thing we could do was turn on that general query log that I talked about, run it through PD Query Digest, and see all of a sudden 4 queries at the top. Yes, those updates and those inserts into the shown user, shown month, and so on tables. And so we went back to the developers and they said, yeah, well, maybe we made this tiny little change. We added a for each somewhere. So after 3 days, it was running 2.5 days behind, and every hour. So And the manager said, you know, it's fine, it'll catch up during the night. No, it won't. And they said, you know, maybe you can tweak the database server a little bit so that during the night it will catch up. We said, well, maybe it is possible to do that, but what's the point of having master-slave setup if your slave is running behind 2 hours during the day and you can't use it to switch to the master? There's no point. So the big question is, why is the slave lagging behind? Because the master wasn't having any issues. So to understand that, we need to look at how master-slave works. And basically, our master here is using 16 cores to process all the database queries. And as soon as the database query is ready and it writes it to disk, it also is going to write that query to a binary log file. It's going to use one CPU core to do that. And that binary log file will contain nothing more than queries, basically. And then the slave is going to copy that file using one CPU core. But then it has to execute each query in the same order as the master did. So the only way to do that is to do it sequentially. One query, then the next one, then the next one. So it can only use one CPU core to do that. That means the master is using 16 or 15 of them. The slave is stuck on one. And one CPU core just wasn't enough to process all those queries. So while the master looked like this and then went up, the slave looked like that. And you can see it's not really going up anymore. You can see a different color here, but it's not rising because it's just not able to cope with it on one CPU. So what's the fix? How do we fix this ugly, well, this beautiful piece of code with a for each around it? Any ideas? Sorry? Getting rid of the for each, yes, but the marketing people don't like that. They want their statistics. Yes, getting rid of the marketing people is a solution. Go ahead. Yes, having one insert with multiple entries. So doing basically this, insert into shown today, values, and then you attach all the values. And then you can still have that on duplicate key at the back. That still works. So instead of having 200 queries, we have only 4, which is kind of an improvement. And the code to do that, it's kind of dirty. You create a piece of string, then you for each across all of those. And then you cut the last comma off, and then you add on duplicate key. That's what they produced. But it took them 2 days, and we couldn't wait 2 days, of course. So we just did this. db auto-commit false, then exactly the same code, and then db commit. So now instead of running 200 queries and writing to disk every time, we did that only once. We run 200 queries in one commit, and we only update the index once instead of updating the index 200 times. And that means it was okay. The slave was catching up slowly again. So for loops are bad. I don't have to mention that anymore. But the issue is that if you add master-slave here, it gets worse, a lot worse. And you could have an application today that works fine with a for loop in there somewhere, and tomorrow your system admin says, I want more redundancy. I'm going to add a slave to the system. And all of a sudden, the whole thing goes down. Using transactions will cause performance increase here, but it might also introduce certain locking issues. So you have to be a bit careful. In our case, the slave called up 5 days later. We haven't had any issues anymore afterwards. So I talked a lot about databases. There's another thing that PHP interacts a lot with. It's, of course, the network, because without the network, we would have no PHP, basically. So I want to talk about this customer, customer Y, of course. They had one of the top 10 sites in Belgium, and they were growing, well, I would say exponentially at the time. And for some reason, between 8 and 10 p.m. in the evening, they would have serious issues on their site. They would lose database connectivity. Certain queries would simply fail. Connections would drop. There would be enormous amounts of latency. Very inexplicable things would happen. And we didn't actually write any code for them, but they called us because they were really stuck. And the first thing we said was, well, do you have any monitoring systems on your infrastructure? And they said, well, we can check if the server is running or not. So what we did was we installed a tool called IPTraf. Anyone know IPTraf? A few people, okay. Basically, it's a tool that will just tell you how much traffic is going across your network port. And we noticed that they were sending from the database server to the web server 98 megabits per second. That was a number that was a little bit too odd for us. So we look at that switch. Turns out its maximum speed is 100 megabits per second. 98 plus a little bit overhead equals 100. So they were just hitting the network limit with whatever they were transferring from database to the web server. So we told them, look, this is your problem here. That's obviously what's going on. And they said, well, great. So they unplugged that 100 megabit switch. They put in a gigabit switch. And they say, thank you for fixing our problem. Send us the invoice. I said, yeah, sure. I'll send you the invoice, but wait a second. Your site is big, but it's not that big. It shouldn't be doing 100 megabits per second or more all the time. So we started digging a little deeper. Turns out they were sending 700 gigabytes a day from the database server over the switch to the web server, and they were sending out 60 gigabytes a day over the web. Something really doesn't add up here. I mean, where is all that traffic going, right? Now, upon investigation, it turns out they were using my favorite tool, Drupal. I'm so glad we don't have a Drupal room here anymore. And Drupal has a system with hooks, and if you build your modules in Drupal the wrong way, then when a hook is called, you can actually attach it to content blocks and stuff like that. It can actually start retrieving data, and then at the end you decide, I don't need it, I'll just throw it away. So they were retrieving lots of information and then not using it at all. So the thing is here, you should only load data that you are actually going to use, of course. If you don't know in advance what data you're going to use on a certain page, then use lazy loading. Load it the very second that you actually need it. Now, if you're thinking, that's okay, I'm caching everything in Memcached or Redis, well, it's basically the same thing. You're still retrieving it over the network. And you're still retrieving it within PHP and processing and then throwing it away. Now, on the network, there's a lot of stuff that can happen that's just different than just overloading a network. So we had this customer, let's call him Z or Z. 150,000 visits a day, which for a Belgian site is pretty reasonable. Oops, let me go back. They had a news ticker on their main page. And that news ticker would basically load an XML feed from a different site. Now, they also owned that site, and they didn't want to overload the other server, so they just cached that feed for 15 minutes. This is the actual code they were using. So we're going to check the file creation time of a cache file, and if it's more than 15 minutes old, then we're going to delete the cache file. Then they're going to fetch the feed from a certain URL and put it in the cache file, and finally we're going to parse that cache file. Can anyone tell me what's wrong with the code? Or what's not wrong with it?
It's downloading that maybe 10,000 times every few minutes.
Yes, it's going to download it many times every 15 minutes. We'll get back to that in a minute. Yes? Sorry? It's doing the parse thing every single time. We'll get back to that. Anything else? Go ahead. What if it doesn't exist yet? Well, I guess yeah, in that case, file C time will return 0. It's a problem if? That should actually work. 2 clients can fetch the file at the same time. Go ahead. Yeah, it starts to delete the file. All of these are true, but it's actually not the problem we encountered.
When
Maybe,
you're checking the file for the first time, the PHP remembers the attributes and need to reset if you want to get a new time.
yeah, still, we had a slightly different issue. Yeah, sorry? Not transactional save, yeah. You can have a race condition actually here, in theory. What actually happened in this case is, so we had our website, and we had the feed location, which was on a different server, in a different data center, and that data center lost power. Now what happens in this case after the cache expires? Sorry? It will try to fetch it, but you will get a timeout. What's the default timeout in PHP? 60, actually. So what happens is each visitor is waiting 60 seconds. Really? They're going to wait 60 seconds? Refresh, refresh, refresh. Let me open a new tab. Huh, my Firefox is hanging. Let me open Chrome. So you get more connections, more connections. At some point, they were using Apache, and they would just hit the maximum connections. Now it's not just that page that's down, it's the entire site that's down. So they call us, we go in, and we're like, wait a second, no load on the system, and there's like 400 Apache processes running. What the heck is going on? Okay, let's restart Apache. That doesn't fix it. It's the same thing almost instantly. So it took us a little while to figure out what exactly was going on. And then the developer came up with this fix. So he's now creating a stream context with a timeout of 5 seconds, and then applying that to the file get contents. Yes, this is a fix. I wouldn't say it's a very good fix, but at least the site was not 60 seconds slow again. Yeah, go ahead.
That would be the guess. The fix would be to outsource the fetch command into the browser.
Yes, we will get to that in a minute. So let's have a quick look at all the other stuff that was mentioned. So for starters, this unlink here, you might have, when the cache expires, you might have a couple of people going into this if structure. And one person might actually unlink it and then fetch the contents, while another person might immediately right after that delete the file that was just put there, which is kind of pointless. So, and then of course everybody goes back into that if structure, so that sort of like an endless loop almost. So let's get rid of that unlink. Don't delete from cache, only push your updates to the cache, only overwrite your cache file. Another thing is that, what is file get contents going to return when there's a timeout? False. So we're actually putting false into our cache file, which is not going to parse very well. So we might want to check for that as well. Someone mentioned we're doing parse XML feed every single time. Why? We could just do that once when we write it. It's a little bit more convenient, reduces CPU usage. But there's actually one thing that wasn't mentioned yet. Oh, actually sort of, but file get contents and file put contents are not atomic operations in PHP. What that means is if you got two people going into this and retrieving that feed, and they're doing file put contents simultaneously, then you could actually get a corrupted file. In the same way, you could have one person doing file put contents and the other one doing file get contents, and the file isn't complete yet. He's reading a corrupted file then. So file get contents, file put contents, bad idea in this case. Plus, we are relying on the user. The user is actually going to decide when the cache needs to be updated, which is a bad idea, because that basically puts the user in control. It might be better to run a cron job every 15 minutes. That's just going to fetch that feed. So we learned, or well, actually that developer learned a lot from this. We should be using timeouts. The default PHP timeout of 60 seconds is a little bit too high for most cases. So when you fetch something from a certain URL and you want to immediately show information to the user, then don't wait 60 seconds. Put a timeout on fopen, curl, soap, rest, anything that requires network activity. And if actually you trust your data source, like in this case, they owned the other site that had the feed on it, why not reverse the process? Why not push any news updates to you? That way, you don't have to go and fetch it every 15 minutes. Plus, you get every single piece of news that's updated, you get it right away, not 15 minutes later. And of course, you should add logging here. You have to know when stuff like this goes wrong. You have to receive an email or some kind of SMS alert. Speaking about logging, very good, I like it. Logging in PHP using fopen, as we saw, not really always a good idea because of locking issues. And there are alternatives. We already saw monologue being mentioned a couple times today. So using monologue, you can basically log to all of those different systems, and you can switch from one to the other without actually having to rewrite your code, which is very useful. For Firefox, there's a plugin called Firebug who uses Firebug. Okay, now there's a plugin for Firebug called FirePHP who uses that. Not so many people. Okay, it's a very interesting thing. It allows you to write directly to Firebug from within your code without actually showing any output to the user on screen. I wouldn't use it on production, but if you really have no other choice, then that's the best way to do it. Now, logging's great, but if you never open a log file, then there's no point in logging, of course. So you have to watch your logs, but equally important, you have to be careful about the logging process. There's a lot of system engineers that will say, okay, on my database server, I put my databases on fast SSD disks, and my log files, I put them on slow, old-fashioned 5,000 RPM disks, because that's okay. But actually, writing to a slow disk can cause a serious I/O bottleneck, and that can actually bring down your machine. Because of excessive writes, database updates, issues with log files, swapping, if you don't have enough memory, is probably the biggest issue. Excessive reads, the same thing. Non-indexed database queries cause excessive reads because you're reading your entire table from disk, usually. How do you detect it? Well, if you're on Linux, who is not running production on Linux? 1, 2, 3. Okay. And the rest is asleep, maybe. But so if you're on Windows, check with your system administrator. I'm sorry. If you're on Linux, just type top, and top will give you some very nice output. It will tell you how much CPU usage by user processes, how much CPU is being used by system processes, how much idle CPU time you have, but also how much I/O weight there is. So in this case, we see 35.5% of the time your CPUs are waiting for your disks to read or to write. That's a lot of time. Then you can drill down using I/O stat. In this case, it's I/O weight 53%. So half the time, your CPU is just busy waiting for the disk. And I/O stat will also tell you on which device. Now, there's plenty of tools that will allow you to drill down even further, up to the point where you can say, okay, this is actually being caused by that specific process. If you see I/O weight, don't worry about your code. Stop worrying about that. Fix your I/O problem first, because that's going to kill your server. So, we talked about the elephant on the database, indexing, avoiding for loops. We talked about external stuff. So it's important for any developer to realize we're talking to stuff that's outside of our code. And it's important to know what we're doing there and what effect it's causing, like on a master-slave, for example. We are transferring that stuff across the network. Do we really need all that data? Are we sending too much data from our database server to a web server? Or what happens if there is a timeout? How do we handle that? Your code should be able to handle that as at least in a sensible way. It should give a nice error message, or it should alert the system administrator. Web server, well, of course, we're processing PHP there. And finally, I didn't talk really about this part, but we can compress stuff, we can cache stuff on the user side so that we don't always have to send it over there, so that we have less PHP to process. So it is not just about the elephant. It's also about the dolphin, it's about the penguin, it's about the devil, and it's about all those other things. And if we want to go from being just PHP coders to being real PHP engineers, then we have to look at all those different things. Which brings me to questions. Any questions? Yes?
With the example where you say not to use file put context, file get context, what would be a good alternative way of doing it?
Yeah, so with the example of file get contents and file put contents, what would be the best alternative solution? The best way to do it there is to use a cron job and just let it run every 15 minutes and not rely on the user to launch that piece of code, and just let the cron job update it every single time. You won't even have to check for the file creation time in that case, because you're just going to override it anyway. That would be the best solution. Yeah, go ahead.
You mentioned that file get and puts are not atomic.
Mm-hmm.
So wouldn't you have the same problem in cron job, that you would actually try to really corrupt?
Yeah, so the question is, the file get contents and file put contents are not atomic operations. Would we have the same issue in the cron job? Normally, not with file put contents, because you're only running that cron job once every 15 minutes, so there's never going to be two of them simultaneously. But theoretically, you could have an issue if you do file put contents without using the proper locking mode. If you do a file put contents and someone's reading at the same time on your site, that could cause corruption. So you have to be careful there. There's a couple of flags that you can use to ensure that nobody can actually start reading that file simultaneously. Go ahead.
Actually true. How much do you have to have requests to actually have that happen? Because it sounds a bit strange to me.
One request could be enough if it's at the exact right time.
But is there really no default locking on the?
Well, so there is a way to change locking mode, and then you don't have that issue. But then as soon as you start introducing locking, you can have some other issues that everything's basically locking. It also depends on the size of your file, of course. If your size is super small, then it's going to write in one I/O operation. If the file is very big, then it could cause an issue. So it depends on the number of factors. And there's a couple of ways in which you can mitigate the issue.
You can bypass that problem altogether by writing the file first to some temporary name and then renaming. So the inodes are different from the PHP process reading the file and the other process writing the file.
Yeah, I don't know if the copy command is... Yeah, so we could fix the problem by writing to a different file first and then renaming the file, basically, or copying it over the other file. Yeah, it has to be a move, yeah. I don't know if that is atomic, but it should be.
It depends on the
'Cause
file
it's-
system, but I'm not sure it's file systems in it.
Yeah, okay.
You could use memcached.
Yeah, I mean, using a caching system like Memcached or Redis or any other system is a lot better in this case, of course. I was illustrating, of course, with a customer example, and they were not as advanced at the time. Go ahead.
Is there any solution or restriction that you can run only one core on the slave? Should you be running multiple instances of the master and slave databases and have one slave core? Or
Yeah, so the question is there a solution to the master-slave issue with the slave only processing on one core? The issue with MySQL is that it normally can only process on one core for one database. A possible solution would be to split up your database across multiple database to split your data across multiple databases. Now, of course, you will lose certain abilities that you can only have within one single database. But then it would be able to run one CPU core per database. So that is a possible solution there. You could also replicate certain tables only to certain slaves. If you have multiple slaves, then you could split it up that way as well. But then you lose the ability to say, okay, I'm going to use my slave as my master immediately. You would have to merge them together again. Okay. Just in case you're from Belgium, we're hiring. If you're looking for a challenge, That's just my 5 seconds of advertising here. I will put the slides on SlideShare. Please provide some feedback. That goes for all the speakers today. We have the URL up here, actually. But if you go to that URL, you can also click through. Please provide some feedback. Tell speakers what you like. Tell speakers how they can improve on their talk. That way they can improve it for future conferences. Thank you.